Hello everyone. Today we are going to solve a very basic network of an electrical circuit. As we can see in this diagram that there are three resistors that are connected to each other through a battery. Looking at this circuit, we can see that there is only a single path for the current to flow through it. So this is definitely a series circuit. Now for a series circuit, we have certain characteristics that I'm going to write it down over here for your ease, which is R total is equals to sum of all the resistors, which is R1 plus R2 plus R3. The current that flows through the network is same in all the resistors, so I total would be I1 is equals to I2, that would be equals to I3, and the total voltage drop is also the summation of all the voltage drop across the resistors. So that would be V1 plus V2 plus voltage drop across resistor 3. In order to solve the network, we actually have to find all these parameters. So in our data, we have R1 is 3 ohms, R2 is 7 ohms, and R3 is 10 ohms. Then we have the total voltage, which is 5 volts. Okay, so we have to find the remaining parameters over here. The trick is that we have to solve for the totals first, and then we can find the rest of these very easily. Okay. So first we will calculate this total resistance. As we can see in this equation 1 over here, that total resistance is equals to summation of all the resistors that are connected in this network. So this would be 3 plus 7 plus 10 ohms. It's going to be 20 ohms. Okay, so our total is 20. Now we can easily calculate the total current through Ohm's law, which is Vt is equals to It RT. So the total current would be equals to voltage divided by the total resistance, which would be 5 divided by 20. So the total current would be 0.25 amps. Since this is a series circuit, so we know that all the currents in the resistor would be same. So I1 would be 0.25 amps, I2 and I3 would be same. Now, when we have all the resistors and the currents, so we can easily find the voltages across them. So V1 would be I1 R1, which is 0.25 into 3 ohms, which is 0.75 volts. V2 is equals to R2 into R2 0.25 into 7, which would be 1.75 volts. Similarly, V3 would be I3 R3, which is 0.25 into 10 ohms, and this is 2.5 volts. So we will write all the values over here: 0.75, 1.75, and 2.5 volts. Now, after your network has been solved, I would just like to discuss a very basic concept of total resistance, which is also known as equivalent resistance. An equivalent resistance is that single resistor of a network that could replace the entire network in such a way that when a voltage V is applied across its ends, a similar current I would flow through it as we were getting for the network. So we can say that this particular circuit is actually an equivalent circuit for this network. Now moving to the practical applications of the series network. As we can see that the total resistance of the network has increased, and it's even greater than the maximum resistance of this network. So R total is greater than R3, and it's greater than 10 ohms, right? Therefore, the total current of the network has decreased. So a series circuit can be used wherever you want to power low voltage electrical components from a high voltage source using a thinner wire. For example, street lights. Originally, they were wired in series so we could use a small gauge of wire for longer runs. So this is it for today. Thanks for watching, everyone. If you're new here, please subscribe to our channel for more content like this. Hope to see you in the next video.